All right, let's go ahead and get started. So this here, I actually think the extra credit everyone had the same. I think so. So let's go ahead and get started. This one here, I am going to skip number 1 because we are going to do something that's a little bit on the shorter side. That was part of the actual test, not extra credit. But this is, you have to use Pascal's triangle. I'm going to focus on number 2 and then on number 3. So find all rational zeros. So this one, step number 1, you need to see if you can factor. Then if you cannot factor, you're going to use the rational root theorem to list all possible zeros. So I'm going to write it out. I tend to write big, so I'm going to write this out a little on the larger side. 7x to the 5th power minus 5x to the 4th power minus 9x cubed plus 5x squared plus 2x. And immediately when I wrote that out, I noticed that there's an x, an x, an x, an x, and an x. So I'm going to factor out that x. I'm going to pull that out. Left over, we have a 7x to the 4th minus 5x cubed minus 9x squared plus 5x plus 2. If you can factor the remainder here, if you can continue factoring, please do so. It doesn't look like we can. We have 5 terms instead of 4 terms. 4 terms is what we can use for grouping. So we're going to use the rational root theorem. One of the things that some of you forgot is if we pull out a factor, that has a secret bubble. And that represents a root or a 0. So in this case, the root or the 0 is 0 for x. Because x is not attached to any number, that number it is attached to is 0. It's nothing. So that means you have a root 0 at 0. So I'm going to do that so we don't forget about it. Let's continue with the other stuff. Let's list out all the possibilities. So again, silly snake puts the tail over its head. So we got 2 over 7 plus or minus 1 plus or minus 2 all over plus or minus 1 plus or minus 7. We have to place all of the numerators on top of all of the denominators. What I like to do is I like to start with one numerator, put it on top of both denominators or all denominators, and then I go to the second numerator and place it on top of both. After I do that, we simplify fractions, removing any repeats. So I have 1 divided by 1, which is 1. Then I got 2 divided by 1, which is 2. Then we got 1/7 and 2/7. Now the question I'm reading again, it's asking for finding all rationals. Okay, finding all rationals. These are all of your possible roots. These are not your actual rationals. Like some of these could work, all of these could work, none of these could work. We don't know. So from here, you're going to take your equation, the factored, so we don't care about this x anymore. You're going to take that equation and you're going to set it up, leaving what I like to call bubbles in your x placement. And you're going to try to, start by 1, start by 2, start by 3, to plug numbers in to see which one of those will give you a 0. So can someone help me out? Someone do a 1, someone do a 2, someone do a -1, someone do a -2. I'll do the 1/7. Just because. So if you don't have a calculator in your hand, please go get a calculator. Do that now, please. Help me out so we can get as much done today as possible so you guys can be successful on tomorrow's assessment. So what did I say? I said I'm going to do the 1/7, so I'll do 1/7. But hopefully something smaller than 1/7. Not smaller, but hopefully the whole number will work. I'm pleased to announce that 1/7 did not work. One worked? One worked? Oh, yay, one worked. Okay, double check that, please. Let's type that in. One worked. But we really don't need to double check because our next step is now using synthetic division to find out what the quotient is. So we're going to say 1, and Brooklyn, that was a positive 1, right? Okay. So positive 1 goes here. Immediately, once it works into your equation, this is another root. So this 1 that you are using is a root or a 0. So you had a 0 from factoring out an x. Now you have a positive 1 from plugging it in and making it equal to 0. So we have a 7, negative 5, negative 9, positive 5, and a positive 2. Synthetic division, bring down the 7. 7 times 1 is 7. Add, so we got 5, 6, 7, that is a 2. 2, add 7. Negative. A negative 7 we're going to add. So that gives us a negative 2. Negative 2 add when we have a 0. We are happy about that 0 because it solidifies, in this case, Brooklyn's answer that 1 is in fact a root. From here, here's R, 0, 1, 2, and 3. Rewrite that out. Because this root is not a fraction, you don't need to simplify this product. It's just going to be just like it is. And I'm noticing 7 and 2s, and I'm doing a little mini happy dance because I'm thinking, can we factor by grouping? I think we can. But let's check. I could be wrong. From these two, I can pull out an x squared, which leaves us with 7x plus 2. And this one I can pull out a negative 1, which leaves us with 7x plus 2. I'm very happy. Extremely happy. It saves us so much time. These must be the same when you are factoring by grouping. Take your x squared minus 1, x squared minus 1, and then write out your 7x plus 2. From here, you can do this kind of in two ways. You can skip this factoring. If you, for example, didn't notice it, you could potentially still get the right answer by just setting it equal to 0 and solving. If you do notice that you need to continue factoring, that's great. Go ahead and do that. So we have x plus 1 and x minus 1. Then we have that 7x plus 2. Now these are considered your factors, right? In addition to that x that we had and this root. This is part of your factors. Not all of them, just part of the answer. But that's not what it's asking. It's asking us to find roots or zeros. So to convert the factors into roots or zeros, set each bubble equal to 0 and solve. So we have x plus 1 equals 0. We have x minus 1 equals 0. And somewhere over here in a thinking bubble, I'm going to have 7x plus 2 equal to 0. All you're doing now is just solving for your x value. So x is negative 1, x is positive 1, and x is negative 2 sevenths. So we have a root 0, we have a root 0, we have a root 0, we have a root here, and we have a root that is actually 0 here. So what is the actual answer? With all of that work, what is the actual answer? Does anyone still need more time before I move this? Okay, that's fine. Go ahead. So I'm going to write out the answer here in a thinking bubble. We had a 0 as a root. We then found 1 as a root. We then have another 1 as a root. Then we had a negative 1 as a root. And we had a negative 2 sevenths as a root. These two ones right here, this is where you use your multiplicities, your mults. So the actual answer is 0, comma, 1 multiplicity, so mult 2, comma, negative 1, comma, and negative 2 sevenths. This stuff right here in the pink, that is the answer. If, however, you listed it out as 2 1s, I did accept that. Even though I did write, like on your page, like it should have been a multiplicity, I did accept you listing out the 2 ones. All right, so for question number 3, it's asking us to write a polynomial function of least degree with integral coefficients that has the given zeros. So it gave us 3 plus I, this is question number 3, and it gave us a square root of 7. So immediately, because it has an I and it has a square root, both of these roots have conjugates. Now conjugates means the symbol in the middle is flipped. So the 3 remains positive. We're not doing anything to the 3. We're just taking this plus, making it into a minus. Now this square root of 7 is just singular. There's nothing really there. So we just make it a negative root 7. So the actual roots that we have are 3 plus I, 3 minus I, root 7, and negative root 7. So we have 4 roots instead of the original 2 that they give us. These other 2 were hidden. They were secret, magically hidden. What I saw was great work. You guys just didn't take the extra step to expand. Write out your roots. So we got 3 plus I, and I like to do it in like a column and row format. 3 minus I, root 7, and negative root 7. After that, we have our work, which then will lead us to our factors. After that, we have to multiply out. So we got x minus, x minus, x minus, and x minus. Inside of that, we have another bubble, we have another grouping, parentheses, 3 plus I, 3 minus I, root 7, negative root 7. And then one of the hiccups that I saw is you guys were, in a way, multiplying things randomly. Don't do that. You are distributing that negative. Sorry, my hand's in the way. You are distributing that negative onto both terms, or in this case, onto that one term. So we have here our factors. We have an x minus 3 minus I as a factor. Then we have x minus 3 plus I as a factor. Then we have x minus root 7 as a factor. And we have x plus root 7 as a factor. If it is asking for factored format, you add a p of x to show that this is an equation, and you are done. However, this is not asking you for factored form. This is asking for just regular, what does it say? Write a polynomial function of least degree with integral coefficients that has the given zeros, not asking for factored. So you're going to take the 2 conjugates that you originally started with, right? You have here in their factored form. Those are the 2 that you're going to multiply first. So I'm going to do a box method. So I have x minus 3 minus I. And we have x minus 3 plus I. Here I'm going to have an x minus root 7 and an x positive root 7. I'm going to do pencil just in case I do make a mistake. So we got x squared, negative 3x, negative ix. We got negative 3x. We got positive 9. We got a negative 3, positive 3i. Then we have a positive ix, a negative 3i, and we got here a negative I times a positive I. This right here is a negative times a positive, which is negative, and I times I is I squared. Be careful, this I squared is in a separate bubble. This negative is outside. You're not squaring the negative, you're squaring the i's. So another way to think of it, I'm going to erase this so I can show you. Another way to think of this negative is saying negative 1 times I times positive 1 times I. So a negative 1 times a positive 1 is a negative 1 times I squared. And then, beautiful people, what is I squared? Negative 1. So now we have a negative 1 times a negative 1, which gives us a positive 1. So that negative, treat it like it's a negative 1 on the outside. Colson, you doing okay? Okay, yeah. All right, let's do it this way here. We got x squared, negative root 7x, or you can put the x in front, it doesn't matter. Positive root 7x. And then we got, again, treat this negative like a negative 1. Negative 1 times root 7 times root 7. Root 7 times root 7 is root 49. The square root of 49 is just 7. So we got negative 1 times 7, which is negative 7. Okay, some of these are going to start canceling out because we have conjugates, which is opposite symbols. Positive and a negative root 7x cancel out. Positive and a negative ix cancel out. Positive and a negative 3i cancel out. That's it. So we have here x squared minus 3 plus 3 is 6x plus 9. So that came from here. And then this guy is x squared minus 7. Now, notice that there are still bubbles. There's still groupings, parentheses. That means this is still in factored form. This is still in factored form. So we got to do the box method one more time. Yes, ma'am. Do I need to? Oh, did I not do that? Did you guys see that? Thank you, Veda, for that. Okay, I saw the 9 and I completely forgot all the work we did with that 1. So technically that 9 should become a what? Should become a 10. Thank you for that. Otherwise we would have gotten the wrong answer. I appreciate that. So learn from my mistake. Don't forget that 1. If you have it, whatever that is. And let's do it one more time, that box method. So we have now x squared minus 6x plus 10, and we got x squared minus 7. So we have, again, I'm doing it in pencil just in case, x to the 4th power, we got negative 6x cubed, we got 10x squared minus 7x squared. What's 6 times 7? 42x, and then we got negative 70. I'm looking that there are 2 things only that we can add. So we got x to the 4th power minus 6x cubed plus 3x squared plus 42x minus 70 as our final, no bubbles, no factors, answer in standard form. So this example is the same that we had on the back side on the extra credit one. So this right here, number 3. And if you flip it over, it's the same method for this extra credit one right here. The one thing I do want to point out, depending on what version you have, please don't treat this as separately unless there's a comma. Comma means separate. If there's no comma, that means all of this is one of your roots. All right, take a quick moment, beautiful people, at your work, and then let me know which questions you'd like for me to cover. Which questions would you like for me to do? So far, we've done twice. All right, so for number 7, we have the one that I'm looking at. It might be different for you. 375 plus 3x cubed. Immediately I'm noticing there's a cube, so I'm thinking it could be a sum of cubes. 3 is not a perfect cube, so we're going to need to see if we can factor that out. So I'm going to divide by 3, and I do get 125. So when we divide all terms by a number, that is our GCF. So 3 is our GCF. Just like when we first did factoring, I did ask you to create an answer box and immediately put your GCF in it. A lot of you forgot your GCF. And you did lose points for that. Okay, so left over, we have 125 plus x cubed. This right here can be put in the format as 5 cubed plus x cubed. That means this is your A, this is your B. If you look over there on the cheat sheet on the board, I did write out the sum and difference of cubes for you along with the difference of squares. So you're looking at that middle formula that says A plus B, A squared in a bubble is A, minus AB plus B squared. So always same, always different, always positive. So we have 5 plus x, 5 squared minus 5 times x plus x squared. Simplify that out. We have 5 plus x. And if you switched it around, that's fine as long as the 5x remained negative. That was fine. And then don't forget your GCF of 3. So that is what I should see in your answer box. And again, if you decide to flip it around, that's okay. That is allowed to flip things around as long as the symbol in the middle stays the same with that negative. Ask me more questions. Take a look. Just whichever one you got wrong, ask me so that I may help you today. Yes, sir? 14. Number 14 is asking you find all zeros, and I did give you a hint on that one. It says this means rational and complex roots that work. So a lot of you on number 14 stopped after you found all your possible, but you didn't actually do anything with them. So we have x to the 4th plus 3x cubed minus 3x squared minus 9x. And that was equal to f of x. And again, depending on what version will depend on whether it is exact or similar. Step number 1, when I was writing it down, I did notice there is an x. So we got to pull out an x. So we got x cubed plus 3x squared minus 3x minus 9. Immediately, just like we saw in the previous example that we did, if you pull out an x, that means there's a root. That root is 0. So when it's asking you to find all zeros, 0 is in your answer now. That is a 0, that is a root. Why? Because we pulled out an x. I'm going to see if I can factor. I see a 3 and a 9 and a 3, so hopefully we can factor this by grouping. We have x squared, x plus 3, and I can pull out of these two a negative 3, and we got x plus 3 left over, doing a happy dance. Because these two are the same, our factor by grouping method is successful, and we got to bring that in. So we got x squared minus 3 in a bubble, and then we got x plus 3, and again, you're writing it once. So if you need to place that exponent of 1, please do so. Whenever you do factor by grouping, you only write it once. From here, again, these are your factors. It's not asking for your factors, it's asking for your roots. So in order to convert your factors into roots, you have to set them equal to 0. I'm going to leave some space down here. And solve for x. We're going to subtract 3. I'm going to shift this up. X is then equal to negative 3. This one we're going to add 3 to both sides. X squared is equal to 3. Now, one of the hiccups I saw is you guys did take the square root, which is fantastic. However, forgot that when you take a square root, when you're solving an equation, you have to place the plus or minus on it. So we are having a plus or minus square root of 3. So here are two roots. One of them is a plus, one of them is a minus. Here is a third root. And then here's our fourth root. If we could not factor, then we do it like we did in the previous example where we use the rational root theorem. Please make sure your phone is put away. It's a little rude and not okay. Thank you. So how does your answer look? Your answer looks like 0, comma, -3, comma. It is your choice if you want to separate a plus square root of 3 and then a minus square root of 3, or you can just do both, plus or minus root 3. I would accept any of that. Any other questions? I can't see, so let's talk one-on-one here in a little bit after I'm done. Yeah. Okay, ask me more questions. I know how you did. Ask me more questions.
9.
Number 9. Number 9 is asking us to factor. We have a 15x squared plus x minus 2 is equal to 0. And I don't know why I took out a calculator hoping for a GCF, but I have a 15, a 1, and a 2. There's no GCF. And x, no x. So what we have here is the only option we can do is the rainbow method. So here's one of my clouds. Here's another cloud. And then we draw the arc. So we have 15 times -2, which is -30. So here, if you're doing the diamond method or the x, we want two numbers that multiply to -30, but when I add them, give me a +1. Any guesses? 6 and 5, -5, thank you. So we have x plus 6, we got x minus 5. Now this right here, I know it's silly to think of it that way, but it is fake. This doesn't exist, this is fake. It's not real. We made it up. So what you do is you take this 15 that you initially multiplied by, and you bring it down and you undo that multiplication that you did. So originally we multiplied by 15, now we have to divide by 15. You must simplify your fractions. You must simplify fractions. So we have x plus, what's 16 divided by 5? 3 goes into 6. 2 times, 3 goes into 5, 5 times. Then we have 5 goes into 5 once, 5 goes into 15 3 times. You must then convert your denominator to be out in front. So the factors are 5x plus 2 and 3x minus 1. They did originally set that equation equal to 0, so we set our factors equal to 0. And that is it. I was not picky about setting it equal to 0 or p of x or f of x. So if you just gave me the factors, I did accept those answers. Ask me more questions. Yes, ma'am. Number 13. On number 13, it's asking you to find all the rational roots for number 12. So let's actually do number 12 and 13 together, as they are part A and part B. So number 12 says x to the 4th power plus 4x cubed plus 5x squared plus 20x is equal to 0. Immediately I see that there is a x, and x, so we got to pull an x out. So we have an x to the 3rd power plus, I hesitated there for a second, 4x squared plus 5x plus 20. Oh, that's equal to 0. Again, immediately when you see that x pulled out, that means you have a root, a 0 at 0. Now, question number 12 did ask for you to list out all your possible, so this is where the 0 comes from, and then you have a secret 1 here. So we got 20 over 1 as part of our silly snake. The silly snake takes the tail, puts it over its head. So we have a 1 times 20 is 20. We have a 2 times 10 is 20. We have a 4 times 5 is 20. In the denominator, we just have a plus or minus 1. So realistically, all we have is whole numbers as our possible roots. So we got 1, 2, 4, 5, 10, and 20. Again, don't forget that you do have a root at 0 because of that x, so we put that 0 in there. So that was question number 12. There was 2 of the correct answers that there was a typo, so we have C and D. If you selected one or both of those, that you did get credit for that. Then number 13 is asking, well, which ones are they? It's only asking for the rational roots. It's not asking for any complex. It's not asking for all of them, just the rational ones, which means we start out by copying down our equation in the factored form. We got x cubed plus 4x squared plus 5x plus 20. And we're going to check to see which one equals 0. So can someone do 1, -1? Which ones can it work? 2, -2, 4, -4. Someone says -4 works. Okay, so let's do -4. So once we're here, we can check it 0, synthetic division. We got -4, got 1, 4, 5, and 20, all of them positive. Bring down the 1. We got positive 1. -4 here, we got a 0. We got a 0 and a 5. We got a -20 and a 0. Again, doing a happy dance when we get that remainder of 0, that means -4 is in fact a root. So now we have 2. We had a root at 0. We have now a root at -4. Let's rewrite this. This is x to the 0th power, to the 1st, and to the 2nd. So that means we have, trying to save space here, x squared. We don't have an x, plus 5. That is our factor. So in order to find what the root is, we set it equal to 0 and solve. Now something you're going to notice that if I subtract 5 on both sides and get x squared is equal to -5, and I continue doing that by taking the square root, I end up getting a square root of a -5. Now, if it was asking for all roots, then we would continue, pull out that negative, get an I, and then that would be part of our answer. Since it's only asking for number 13 for rational zeros, I mean real zeros, real numbers, fractions, just rationals, then the only ones that were real were a -4 and 0. So for question number 13, we only had 2, and that was 0 and -4. If it was asking for all, we would have a lot more. We'd have 2 more. Any other questions? Yep, absolutely. Any other questions on the practice? Any other questions on the practice? So you know what you missed. You know what you missed. Okay, going once. Yes, sir, go ahead.
9.
Number 9. I think we did number 9 already. We did do number 9. It might not look exactly like yours. Oh no, what happened? That was weird. We did do number 9. It might not look exactly like yours, but the steps are going to be exactly the same. Yes, sir, go ahead.
Number 6.
Number 6. Number 6 is saying 40r cubed plus 5r squared minus 64r minus 8. Whoop, you guys can't see. First thing I notice is that I have 4 terms. 1, 2, 3, 4. I've also noticed that there is no equals. Not that it matters. Sometimes they'll do a 0, f of x, p of x. It doesn't really matter because it's asking you to factor. I'm noticing there are 4 terms. We only know one method for 4 terms, and that is factor by grouping. Make sure to check for a GCF. That was the number 1 hiccup. Check for a GCF. R, no R. Sound like a pirate. No. 45, 64, and 8. Doesn't work with a 5 and 8. So therefore, let's just group these 2 and these 2 and hope we can do something with GCFs. From here, I can pull out a 5r squared. Left over is, what's left over? Is that an 8? 8r. Then we have a plus 1. Next one, we can pull out a negative 8. Left over r plus 1. Because we have 2 same things, we have this one and this one being the same, and it has to be the same. If it's not, you've done something wrong. We combine them and we write it once. They are the same, we write it once. These two, we're going to combine them and we're going to do exactly what it says. 5r squared minus 8. We're not multiplying them, we're just writing them next to each other. Because there was no GCF, we are done. That is it. Choose to write that exponent of 1 or not. That's up to you. However, make sure you only write that bubble once. Not twice, once. Any other questions? Yes, sir. Number 10. Did we do number 10 already or no? Nope. Okay. All of them are starting to sound the same. Okay. Number 10, it's asking for you to use the rational root theorem to factor. So the question is factor. Anytime you see factor, think bubbles. That's how your answer should look like. It should have parentheses, they should have bubbles. We have f of x is equal to 2x cubed minus x squared minus 5x minus 2. If you can factor, do it. If you can't, you have to use the rational root theorem and list all possibles. I have a 2, an x, and an x, and then I have 5 and a 2. So we can't factor by grouping, so we have to use the rational root theorem. So we got a silly snake, tail over its head. Got a 2 over 2, which means my factoring is 1 and 2. And my factors on the bottom are 1 and 2. Meaning I have 1 over 1, 1 over 2, 2 over 1, and 2 over 2. All of these are pluses and minuses. Go back in and simplify. I got 1, I got a 2. Why does it look like, oh, this should be a 2. So this is just 1, this is just 2, and a 1/2. So these right here are not your factors. These are just possible roots, zeros. These are just your possible roots and zeros. From here, take your equation, write it out, put bubbles anytime you see an x, and then check to see which one gives you a 0. Does anyone already have this version and can give me a 0 to save time? No? No? Okay, let's check. Can someone plug in a 1? Someone said -1 works? Okay. So someone said -1. And again, we're going to have to do a synthetic so we can check if -1 works that way. So we got 2. Oh, you guys see that? What am I writing here? Am I writing here a 1 or what am I writing here? -1. Ooh, be careful. Do you see that? The coefficient of that right here is a -1. So be careful of that. -5 and -2. Bring down the 2. We got -2 plus u. We got a -3. We got a +3. We got a -2 and a +2. And yes, in fact, -1 is a root. Now, because it is a root, we need to do something with it in order for it to become a factor. So right now, -1 is a root, not a factor. Let's continue. This is your remainder, your 0, your 1, and your 2. We have, that means 2x squared minus 3x minus 2. Trinomial, leading coefficient is not 1. We can see if we can factor. We can try to factor by using the rainbow method. If that doesn't work, then we continue using the possible 0. So let's just check real quick. I'm going to do it using a pencil in case it doesn't work. I'm not sure if it will. X squared minus 3x minus 4. We want two things to multiply to a -4 but add up to a -3. Is it me or is it 4 and 1? Yeah? Does that work? 4 and 1? Okay, I see head nods. Good. So these right here, now that I know that it works, I'm going to copy it down in pen. These right here are your factors. So we have 2 bubble factors and we now have a root. So in order to convert your root into a factor, we got to do opposite of what you see. It's kind of like we did originally. Let me see if I can find it real quick. I probably won't be able to. This one right here. Whenever you're doing that x minus, in our example number 3 for the extra credit, that was when we did the opposite of what we see. So what we do with that root is we do x minus, and then we bring in that minus 1. You don't have to do this. If you can mentally just change the sign, just mentally change the sign. So that means our factor for the root of -1 is x plus 1. So how does our answer look like for this question? I'm going to do it down at the bottom in a thinking bubble for our answer. We had a factor of x plus 1. We have another factor of x plus 1. We had another factor of x minus 4. Now this right here, I'm going to highlight it. If you gave me 2 bubbles of x plus 1, I did accept it. However, that is incorrect format. So whenever you have 2 of the same things, you put it squared. So x plus 1 squared, x minus 4, and what did they have it equal to? F of x in the beginning? This right here in this box, that is your correct format answer. This one right here that I'm highlighting in orange, that was your answer for number 10. And again, depending on what version you have, yours is going to be almost identical, just with different numbers. Steps are the same. Yes, ma'am? I did not care about it. It is more correct if you do. So like whatever the equation originally had, that's what we want to keep it. So if it's like equal to 0, place a 0. If it's equal to f of x, place an f of x. How are we doing? Any other questions for me? Nothing but an A+ tomorrow? 11? Number 11, it's asking you to write a polynomial function of least degree in factored form with integral coefficients that has the given 0. So again, keyword here, it is bolded and capitalized factored form. Factored means bubbles. So whenever you see factored, means give me the bubbles. So 11 for me, it says -4, 3 minus 2i. 3 minus 2i does not, there it is, have a parenthesis, excuse me. Let me try again. 3 minus 2i does not have a comma. No comma on 3 minus 2i. So that means this whole thing is one root. The -4 is also a root. -4 is just a number. I ate 4 apples. I mean, it's that. Here it's random and it's imaginary. Like it has a 3 minus 2 and then a letter, I. So whenever you have a complex root, anything with i's or anything with square roots, that has a conjugate. A conjugate is where you take both terms, keep them the same, and the only thing that changed is the symbol in the middle. So you have a plus here, you're going to have a minus there. If you have a plus here, you're going to have a minus there. The 4 is just a number. It's not attached to a square root. It's not attached to a letter. Leave it alone. I like to do this in rows and columns, so I'm going to write out my roots. I'm going to say -4, 3 minus 2i, and 3 plus 2i because of the conjugates. Then we're going to show our opposite of what we see, so x minus. And then I did post another video on number 11 previously on Google Classroom. So there is another video talking about how to write out your equation in factored form. So then we're going to go back in with another parenthesis and copy it down. So here's -4, here's 3 minus 2i, here's 3 plus 2i. And again, this is a mistake I saw. Just distribute that minus onto everything. So here we have our factors of x plus 4, x minus 3 plus 2i, and x minus 3 minus 2i. If it is asking for factored form, that's it, you're done. Your answers are factors of x plus 4, x minus 3 plus 2i, x minus 3 minus 2i. This right here is in factored form. This is your answer. If it does not say factored, then, oh, you guys can't see, sorry. Then you must continue to multiply using the box method we did for question number 3 on the extra credit. Ask me one more question. Ask me one more question. Ask me one more question. Page 1 was pretty solid. I was very impressed with page 1. Page 2 and 3, I worried. But I think we went through all of them, no? Oh, let's do number 7 before you pack up. No one asked number 7. I want to do number 7. Did we do number 7?
Yeah, we did.
Oh, we did. All right, then. That's it. Enjoy the rest of your day. Pack up.